So now next product about two vectors, that's called the vector or cross product of two vectors. Dot product we already discussed. So here we take two vectors, vector A which has these three components A1, A2 and A3. These are the components of the vector. The other vector B, let's write B1, B2 and B3. So we have started with two vectors with their components are A1, A2, A3, B1, B2, B3. Then their cross product, they cross, or you can just write the vector product. Cross or the vector product is here defined in this way: vector A cross vector B, that's equals to, it's a determinant, remember here, where first row is fixed, I, J, K, remember. First row is fixed. What about the second row? That's a member of this, that is here A1, A2 and A3. Components of A. What about this? B1, B2 and B3. This is a definition of cross product of two vectors. If you expand this the way we did expansion of determinant, your answer will be here some expression into I cap. You know what is this expression? This into this minus this into this minus this into this minus this into this into J cap plus finally this into this minus this into this into K cap. So what you are getting here, what's a cross product of two vectors? This is a vector, remember. So the first thing we note here, we note that the cross product of two vectors is a vector, is a vector. If you remember, dot product of two vectors is a scalar, but here cross product of two vectors is a remember, a vector. Answer will be a vector. Second thing, if I write B cross A here, then these two rows will get interchange. So the value of the determinant would be opposite. So obviously, if you find A cross B and if you find B cross A, they will differ by minus sign. So we have minus here. If you remember, in dot product both were equal. Just recall the dot product. Vector A dot vector B, that is equals to this dot this. These two are equal. Dot product is commutative. Here, if you change the order, you have minus sign. Why this? This just follows from the property of the determinant. If I write B cross A, then these two rows will get interchanged. So obviously you have minus sign in front of this. Fine. So this is second one. Third one, if I write cross product of a vector with itself, A cross A, then what happens? These two rows will be identical. So value of the determinant will be 0 I cap, 0 J cap, 0 K cap. So it will be null vector, remember. So cross product of a vector with itself gives us what? Remember, here it is a null vector. Just recall in a dot product what we were getting. If you remember, this was very important point in the previous exercise. Dot product of a vector with itself gives the magnitude of vector whole square. Here it is a null vector, not 0, remember, it's a null vector. Fine. So that's one thing. And here if I take theta as the angle between two vectors, for example, this is one vector A, this is the other vector B, for example, here. Then, and if I take the theta as angle between these two vectors, then it can be shown that the sine theta equals to magnitude of cross product of these two vectors upon individual magnitudes, remember. What is theta there? Theta is angle between two vectors. Theta varies from where to where? 0 to pi. Right, as we did. In the formula of the cos theta, you had dot product in the numerator. Here your cross product in the formula of the sine theta. What is the theta? That is angle between two vectors, remember. Angle between two vectors. Fine. So if theta is the angle between two vectors, then sine theta equals to modulus. Modulus is there, remember, in the numerator. In the formula of the cos theta, you were not having the modulus. Recall cos theta, it was simply vector A dot vector B upon individual modulus. Please be careful. In the formula of the cos theta, there you have dot product but without modulus. In the formula of the sin theta, you have modulus of cross product of two vectors upon individual modulus. So let's recap this four thing. Cross product is a vector. Dot product is a scalar. Cross product, if you change the order, you have minus sign in front of it. Cross product of a vector with itself gives us 0. Why? Because these two rows will be identical. And if two rows are identical in the determinant, you know value will be 0, 0, 0. So 0 I cap, 0 j cap, 0 k cap, which is null vector. Whereas in dot product, you had modulus whole square. If the theta is the angle between two vectors, then sin theta is expressed by this. Remember, what's the sin theta? That is modulus of vector A cross vector B upon individual modulus. In the formula of the cos theta, you had a dot product in the numerator and individual modulus. Here we don't have modulus in the numerator, remember. Fine. Now, here further, the fifth one, if I have these three unit vectors, you know these are the standard unit vectors. Which are the standard unit vectors? I cap, j cap and k cap. Now if you do the cross product here, it can be verified once I do some simple examples here. If I find I cross j, right, then it will be k, remember. Next, if I do, for example, j cross k, then it will be I cap. It's a cyclic. If I write like this, for example, here, let me write I cap, here j cap, and here let's write k cap. Then it will be in this cycle. This way, and this way. If I do the cross product of these two, I'll get this. See. If I do cross product of j and k, I'll get I. The next, suppose I'm doing cross product of k and I in this sequence, k and I must get j. It is in this cyclic, remember. I cross j is k, k cross I is j, and j cross k is this I. In this cyclic it is true. If you remember, dot product were 0. Okay. So that's one more thing. This you can prove very easily. Like, see, if I do here I cross j, I'm doing this. Okay. What is cross product? It's a determinant. First row always fixed. I, j, k. Tell me components of I. What are the components of I? 1, 0, 0. What are the components of j? 0, 1, 0. You know this, right? Components of I, 1, 0, 0. Components of j, 0, 1, 0. Now I'm expanding. So 0 minus 0. So 0 into I cap. Minus now 0 minus 0 into j cap. Plus now 1 minus 0, 1 into k cap. So what I'm getting here? 0, 0 and k cap. So just k cap. So I cross j here, it will be k cap. Fine. Now the next important result you can say, so let me write here as a result. That's a distributive property. The one is this, if the cross product is here distributive over the addition, it's like this. For three vectors, if I have A cross, for example, B plus C, then you can just open the bracket. Vector A cross vector B plus here vector A cross vector C. What is this? This is simply distributive property, remember. This is just a distributive property. What I did, A cross B plus C. So A cross B plus A cross C. This is called distributive property, remember, for cross product over the addition. Even same property also holds true for dot product. If you have vector A dot B plus C, then again you can open the bracket. That is this dot B plus this vector dot C. This is a number, this is a number, this is also a number. Here this is a vector, this is a vector, this is a vector. This is also a distributive property, remember. So distributive property of dot product over addition always holds. Distributive property of cross product over addition always holds true. These are very standard distributive property. The third thing here, if you have some scalar lambda, for example, with vector A cross B, then you can just take the lambda outside. It is not necessary that the lambda should be common in both, remember. Okay, that's what this property says. If you just observe carefully, what's the meaning of this? That means lambda is common in which row? Second row. So you can take it outside. So you'll get inside the bracket, you will get one more determinant. It is indirectly property of what? Determinant, remember. All these things follows from the property of determinant. Lambda is a scalar. If lambda is common even in the first vector, you can still take this till the lambda outside, that scalar outside. Even if I have like this, for example, vector A cross scalar vector B. Suppose I have like this. Still I can take the lambda outside. You can see lambda is common with the second one only. So I can take lambda outside, vector A cross vector B. Right? So where lambda is a scalar. That way you can use this property. What's the meaning of this? Lambda is common here in the third row. And you know, if you have some constant common in any row or column in the determinant, you can take it outside. So we have this. So one is distributive of cross over the addition, distribution of dot product over the addition, and if you have scalar common with one vector, you can take it outside, remember. Okay, now next point is here. So we start with two vectors here. Let's take two non-null vectors. We start with two non-null vectors. Now the first question is what's cross product physically. So if I have one vector over here, this is vector A for example, and I have another vector over here, vector B for example, then a vector that is perpendicular to both, that is this vector, remember. This represent cross product, the standing vector. For example, this is a vector A or B. For example, this is nothing but the vector for A here. Let me take this as a vector A. Okay, so this is vector A here, this is vector B here, then this represent A cross B, a vector which is perpendicular to both, remember. So direction of the cross product is always perpendicular to both the given vectors. So this is one vector, this is the other vector, then the vector which is perpendicular to both, the standing vector. This represents the cross product. So I'll write here, let me write a vector perpendicular to both vector A and vector B is the cross product, is this. Fine. Now direction of this is according to right hand thumb rule, you know it. Now it is quite possible that if I have two vectors like this, here I have two vectors. Okay, these are the given two vectors. And here if I take a vector in this direction, for example, so then this represent A cross B. If I take exactly in the opposite direction, then this is minus A cross B, opposite, remember. So you can consider these also, remember, or you can consider minus. So I can write here or minus cross product of these two, remember. that is in the opposite direction, one in this direction and one exactly in the opposite direction. So minus a cross b. Now I want to make it unit, remember. So how do I make it unit? So I'll write just divide by its magnitude. So let me write unit vector perpendicular to both vector A and vector B is equals to cross product upon its magnitude. So we'll get the unit vector we already discussed earlier. And you may have in the opposite direction. So here plus, if your opposite direction, you can put the minus. So in general, you can write plus or minus. So these are the vectors. There are two vectors. One is a vector and the other one is vector which is in the opposite direction of the given vector. I repeat one more time. Suppose these are the given two vectors. I have two vectors. Right? These are the two vectors. I can take one like this. This represent what? A cross B. This is A cross B, perpendicular to both. And one more I can take exactly in the opposite direction like this. This is minus A cross B in that sense. Okay, so we have this a unit vector perpendicular to both these and this is given by plus or minus cross product upon its magnitude. Fine. Now next we want to get the area of a triangle. Area of a triangle here in R3, remember. So we have a triangle, for example. This is a triangle where we take the two side vectors as vector A and vector B. So this is vector A, this is vector B. So triangle with side vectors with, remember I'm emphasizing on the word side vectors. These are not the position vectors of the vertices. Side vectors, vector A and vector B is given by half magnitude of cross product of two sides. Remember, this can be proved, not a big task, but if you observe, this is indirectly a determinant. So we had the same formula even in the determinant chapter also, half modulus D, if you recall. Here half cross product of two side vectors with magnitude, remember. Any two, you can take these two also. What is important one here, we must notice that vector A and B are nothing but what? Side vectors, remember. Don't get confused with the position vectors of the vertices of this. So it is given by 1 by 2 with magnitude of cross product of the two sides. Fine. So this way we get the area of a triangle in R3. Earlier we had in R2 two coordinates. Here vector may have three components, remember. That's one thing. And next point is area of a parallelogram. The next one, that is area of parallelogram. So we have a parallelogram. You know, in a parallelogram, opposite sides are equal or parallel. So this is, for example, parallelogram whose sides are given by these two vectors. So one side is vector A, the other side is vector B. So opposite sides must be here vector B, remember. Your opposite side must be vector A. So this is a parallelogram. You know, diagonal is A plus B. And very easily we can see that, or even you know that the area of a parallelogram is summation of these two triangles. So here what is this? A and B, these are nothing but the side vectors, remember. Again we are emphasizing on what? Side vectors. So area of the parallelogram is given by here just cross product of these two sides. Cross product of two sides, remember. We won't be having half in front of this here. Half will not be there. If you have just cross product of two sides with magnitude. Because why half will not be there? Because it's the double of the area of the triangle. But in case if you have here, as a remark I'll write, if you have a parallelogram, let me write a parallelogram where you are given two diagonals. Two diagonals you are given, vector, let's write A and vector B. Right. What is this? Your vector A and B are nothing but the diagonal vectors. If you are given diagonal vectors in a parallelogram, then area equals to, there you have half magnitude of cross product of two diagonals. I repeat, what I'm telling you here, if you are given diagonals vectors as vector A and vector B in a parallelogram, then area would be half magnitude of cross product of the two diagonals. But if you are given side vectors, then you won't be having half, directly magnitude of cross product of two sides, remember. Okay, so I think with this now we can go to the next exercise, that's exercise 10.4. So let's see the first question there. Exercise 10.4, first question. Question number 1. Okay, what you are asked there, find the magnitude of cross product of these two vectors. Vectors you are given here, I cap minus 7j cap plus 7k cap. The other vector B you are given 3i cap minus 2j cap plus 2k cap. So let's get the cross product first. How do we get the cross product? By just writing what? Determinant. So here cross product equals to determinant. First row is always, I, j, k. What's the second row? Second row, components of this. What are the components? 1, minus 7, 7. Here 3, minus 2 and 2. Now we just expand this as we were expanding in determinant. Here I cap, what is this? How do we do this? If you just recall, this is nothing but the minus 14 plus 14. Minus 14 plus 14, so 0 I cap minus, what about this? 2 minus 21, so it is minus 19 j cap into j cap plus, what about this? Here minus 2, here minus 2 plus 21, so this is nothing but the plus 19 k cap. So you are getting here 19 j cap, this is just 0, plus 19 k cap. This is their cross product. This is a vector. If you want to write in terms of scalar, 0, 19, 19, remember. But we want what? Magnitude. So therefore magnitude of this, that's equals to square root of 0 square, which is 0, 19 square plus 19 square. So you can take 19 square outside, it will come as a 19. This is 0 plus 1 plus 1. So you have finally 19 root 2. That's required magnitude here. So it's so simple. Cross product is even not difficult, remember, for us. It's just based on determinants only. In the next question, you are given two vectors, vector A and vector B. You want to find a unit vector perpendicular to each of these two. Which two? Their addition and their subtraction. So we need to find this first. So we add these two. 4i cap plus 4j cap, and this is 0. 0k cap. Okay. The subtraction, there's 2i cap. This is 0 here. 0 j cap, and this is plus 4k cap. First we add them. If you add them, this is 4, 4, and this is 0. Right. Now if I subtract this minus this 2, this is 0 and this is 4. Okay, so we have these two vectors. Now you want a vector that is perpendicular to these and this. So when you have perpendicular to two vectors, we need to use what? Cross product, remember. So I'll write here required vector. Required vector means what? vector that is perpendicular to both, remember. Which two? These and this. So you can call this as just vector x, and you can call this as vector y, for example. X is this vector, y is this vector. So plus or minus, what you need to do? Their cross product upon its magnitude. This is what the formula we have stated. Very important result, remember this one. What is this? This is a unit vector in the question you are asked. This is a unit vector which is perpendicular to both x bar, vector x and vector y. Vector x means this and vector y means this. Fine. This is very important result when you are asked vector perpendicular to both, remember, or each. Okay, now we get the cross product first and we just place there. Just find the cross product of these two vectors. You know how to find this. Here I, j, k. Okay. What is vector x? That is 4, 4, 0. That's vector x. Here it is 2, 0, 4. Fine. Now we get the cross product. That's simply determinant. 4 into 4, 16 minus 0, so 16 I cap, minus 16 minus 0, which is 16 j cap, and plus, what about this? This is nothing but 0 minus 8, so minus 8 into k cap. I repeat, 4 into 4, 16 minus 0, 16 I cap, 4 into 4, 16 minus 0, 16 j cap, plus this is nothing but the 0 minus 8 k cap. So you have this. This is the cross product. Now we get their magnitude. So now let's find the magnitude. Magnitude of these two vectors, which we required the magnitude here. So 16 square, here also 16 square, and here we have 8 square. You can take at least 8 square outside, so it will come as 8. So here you are left with 2 square, which is 4. Here you are left with 2 square, which is 4. And this is just 1. So we'll get the 8 into 4 plus 4, 8, 9. So it is just 3. So we'll get the 24. That's their magnitude. So finally, the required vector equals to, therefore, we'll just come back to this. Required vector equals to, we have plus or minus, what's the cross product? That is here. 16 I cap minus 16 j cap minus 8 k cap upon their magnitude, which is 24. So you can write plus or minus. This is nothing but 2 by 3 I cap minus this is 2 by 3 j cap minus this is 1 by 3 k cap. These are the two vectors, remember. Unit vector which is perpendicular to one vector this and the other vector this. This vector, there are two vectors. One is in this direction, you can see, and the other one is in opposite direction, like this, that way. This is x bar cross y bar, which is perpendicular to these two vectors, like this, if I show you, right? If I have these two vectors, then this will be perpendicular to both this, that is their cross product, and in the opposite direction, so your minus, as I mentioned. Okay, so this is a required vector. It's a good question. Let me write important one here. Okay, now next question number 3. What the next question says? That's also nice question, third one. Find a unit vector A. Okay, so I'll take vector A equals to A1 I cap, A2 j cap, and A3 k cap. You can just write A1, A2, A3 like this in form of scalar components, the vector A. We want this vector. That means you want A1, A2, A3 indirectly, which makes pi by 3 with I cap, pi by 4 with j cap, and theta with k cap, and hence find theta and components of this. So we are given these three things here, remember. What's given? Given that pi by 4 with I cap. pi by 3 with I cap. So cosine pi by 3 equals to vector A dot I cap upon their magnitude. Pi by 4 with j cap. So cosine pi by 4. Have you realized I have used the formula to find the angle between two vectors? Here vector A dot j cap upon their magnitude. Fine. And one more, and let me write here, and one more cosine theta with k cap. So vector A dot k cap upon the magnitude. Fine. Now you are given that this should be unit vector, so obviously this magnitude should be 1, remember. So here if I come to this, what's cos pi by 3? You know, this is 1 by 2. What are the components of this one? A1, A2, A3. You take the dot product with I cap, so you'll get just A1. This is 1, magnitude of I cap is 1. What's cos pi by 4? 1 by root 2. Dot product with this. Here what will get? Just A2. Upon, this is 1, this is also 1. What about this? Cosine theta equals to dot product with k cap. So we'll get just A3. This is 1, this is 1. Right? Fine. So you got A1 from this. What is A1? 1 by 2. First component you obtain. What is that? 1 by 2. What's the second component here? That is A2 equals to 1 by 4. 1 by root 2. Fine. And here we have A3 equals to cos theta. Now we want the theta and A3 both. So we use here this information. Which information? As magnitude equals to 1, so you will get the A1 square plus A2 square plus A3 square equals to 1. Just use the definition of modulus. You can square it. So 1 square is 1. And what's the definition of magnitude? You know. What is A1 square? 1 by 4. What's A2 square? 1 by 2. A3 square as it is equals to 1. So let's simplify this. So from this you will get the A3 square equals to, what is this? This is nothing but 3 by 4. I'll take on the other side 1 minus 3 by 4. So that's just 1 by 4. Fine. So A3 has to be what? Actually plus or minus 1 by 2. But just read the question. You are given that theta should be acute angle. So it should be just 1 by 2. Fine. Actually it should be plus or minus 1 by 2 when you take the square root. But why we wrote only 1 by 2? Because in the question itself you are given that this should be acute angle. So it has to be positive. And therefore finally cos theta equals to 1 by 2. And therefore theta has to be pi by 3. So theta is pi by 3. And components of this one, what are the components of this one? A1, 1 by 2, A2, 1 by root 2, and A3, 1 by 2. These are the components. This is answer to second question, components of vector A and the angle. Now here, many of you might have, for example, confusion why this is A1. So I'll just show here in rough. Dot product vector A dot, let me write I cap. What is A1? A1 comma A2 comma A3. That's vector A dot I cap. What is I cap? 1 comma 0 comma 0. Now dot product A1 into 1 A1 plus A2 into 0 0 plus A3 into 0 0. So therefore we are getting A1. And therefore I wrote A1 here directly. I think that's obvious, but still I've shown. Same way, if you do the dot product here, then you will get just A2 here. This 2 will be 0. That's why this is A2. If you do the dot product of these two, this 2 will be 0 and 1, and therefore you will get the A3 here. The other things are quite obvious here. Fine. Now the next question, question number 4, fourth question. Let's see that. You want to show that LHS to RHS expression. What's LHS expression? You have this vector A minus vector B cross vector A plus vector B. So simply distributive property, right? We open the bracket in simple language. So I'm opening the bracket. This cross this, you know this, ये आपको पता है. This cross this, plus sign, remember. Vector A cross vector B. Now this with this, minus vector B cross vector A. Finally plus, sorry, it will be minus, I'm sorry, this is minus B cross B. Now just recall from the cross product, what is this? You know that this is zero vector. Cross product of a vector itself is zero vector. This one as it is because you want this one right now on the RHS. You change the order, so your minus and this minus gives us plus. So plus the cross product of these two. If I change the order, one more minus and minus is this, so this will be plus. And what about the last term? It will be again null vector. So this will be double here, twice vector A cross vector B, right? And that is nothing but your RHS. Therefore, true. Okay. Fifth question, you want to get those two unknowns. Which two unknowns? One is lambda, we find there one scalar lambda, and the other one is mu. You want this if the cross product is null vector. Okay, so here you want to do the cross product of this 2i cap plus 6j cap plus 27k cap cross, what about the other vector? I cap plus lambda j cap plus mu k cap equals to null vector. I'll write the cross product of these two. What is RHS? That is, you know, 0, 0, 0, 0, comma 0, comma 0. Here it's this determinant, you know. Which determinant? I, j, k. Right? It is the determinant I, j, k. What's the second row here? That is here 2, 6, 27. 2, 6, 27. What is the third row here? 1 lambda mu. Here 1 lambda mu here, remember. 1 lambda mu. Now you must realize what is to be done. Just expand this and compare with 0, 0, 0. So here I am doing C. 6 into mu minus 27 lambda into I cap minus 2 into mu minus 27 into j cap plus, what is this? 2 into lambda minus 6 into k cap equals to what we have? 0 I cap plus 0 j cap plus 0 k cap. Compare the corresponding components. That's what you need to do now. So you'll get the immediately lambda and mu. So no need to compare this. You just compared this one directly. So you'll get the mu from this. Second compared with the second one. So minus 2 mu plus 27. This minus will go inside equals to 0. So what is mu from this? 27 by 2. And you compare this with 0 again. So 2 lambda minus 6 equals to 0. Last component with the last component. So lambda equals to 3. So lambda is 3 and mu is 27 by 2. Lambda is 3 and mu is 27 by 2. Okay.